Okay, ladies and gentlemen, we're going to verify trig identities. Now, previously, we simplified trig identities. In simplifying trig identities, we took something like this statement here, and we made it as simple as we could. The problem is we weren't sure where to stop. Now, in this case, since we're verifying, we actually are doing more like a geometric proof, where we have something that we want to turn into something else very specific. So we're going to do it in a very similar way. We're going to make statements, and we're going to have reasons, but we're going to be moving from here to here. Now, by the way, I could have moved from here to here. The reason I'm starting on this side is it's more complicated, which might seem counterintuitive. But the more you have to work with, the more complication you have to sort out and simplify, the easier it is. Rather than figuring out what's not there and trying to put it back in, it's easier to take what's there and get rid of it. So, with that, let's go ahead and start our first verifying trig identity. First things first, the first statement I always put is given. Now, after that, I take a look at this and I grab my trig identity sheet, because without my trig identity sheet, pretty well lost. I'm going to say, okay, what over here looks like something I might need? Now, I do know that cosine squared is 1 minus sine squared. Well, maybe, but then I'm still stuck with this secant squared thing. As a general rule, I like to get rid of things that aren't sines, cosines, or tangents, because I'm a whole lot more used to working with sines, cosines, and tangents. So when I can, I do that. Now, in this case, I have tan squared plus 1 equals secant squared. Well, that's not this, but if I move the 1 to the other side, it can be. Tangent squared equals secant squared minus 1. Okay, so with that, I am going to replace secant squared minus 1 with tan squared theta times cosine squared theta equals sine squared theta. And that was done with Pythagorean theorem. Now, from here I say, okay, how do I get these into sine squared? Well, again, I have tangents. I prefer sines and cosines. So let's change that into sine squared theta over cosine squared theta times cosine squared theta equals sine squared theta. Again, you don't have to keep writing this side down because it's not going to change. I just have to keep writing it down to make sure you understand it's still there. This happened by using the quotient property. So by quotient property. Now at this point, hopefully everybody can see what you do next. That's right, cancel out the cosine squareds. That leaves sine squared theta equals sine squared theta, and that was by simplify. Okay, so there's your first one. Let's do the second one. The second one, let's go with a secant theta over sine theta minus sine theta over cosine theta equals cotangent theta. Now, it's verifying trig identity because this is a trig identity. It's just not one that's so common that we need to memorize. If we memorize only a few key trig identities, all those, that allows us to solve way more trig problems than we would otherwise. All right, at this point, this is obviously the more complicated side, so let's start there. With that, I have two fractions separated by a subtraction sign. Well, anytime I have two fractions separated by a plus or minus sign, I'm going to go for some common denominators. So over here, cosine theta, sine theta, and I multiply everything through. I have cosine theta secant theta minus sine, well, I got two of them, so sine squared theta, all over. Don't forget your denominator. It's still there. Cosine theta, sine theta, cotangent theta. And so I have given, and I have common denominators. So we have those. With that, let's go see what we can do. Well, cosine times secant. Cosine and secant are reciprocals of one another. So they're going to cancel out and make 1. And so I have 1 minus sine squared theta over cosine theta sine theta by reciprocal property. Now, with that, I say 1 minus sine squared. Everybody should memorize that, know it by now immediately. That equals And the answer is sine squared equals 1 minus cosine squared, and cosine squared equals 1 minus sine squared. That is cosine squared theta over cosine theta sine theta. And that is by Pythagorean theorem. Now, at this point, you say, hey, I have cosine top and cosine bottom, and there's no plus or minus signs left. Get rid of one out of the top and one out of the bottom. Leaves cosine theta over sine theta by simplify. And cosine theta over sine theta is cotangent theta, which is by quotient property. So, we have that. All right, there's your second identity.